Hi, Kim Peeps. Let's talk about electrons, protons, and neutrons and nuclear notation. On my screen, you will see a general format for nuclear notation. Let's just quickly go over the different parts. The large X represents the chemical symbol of the element, which you can find on the periodic table. The A represents a superscripted number, which is called the mass number. It will probably be given to you. That tells you the protons and neutrons in the atom. And then the Z is a subscripted number called the atomic number, which you can find for that element on the periodic table. Let's go to the periodic table and let me show you where that atomic number can be found. Here we see the periodic table, and carbon is found right here. Carbon has a little 6 above its symbol. That represents the atomic number, which is unique to carbon. As long as the atomic number is 6, it will always be carbon. There isn't one other element on this table that has an atomic number of 6. This signifies the number of protons in the nucleus. What's really cool about this number also is it can be the number of electrons if the atom is neutral. And I know it's neutral if it doesn't have a plus or minus charge on it. So here is carbon's nuclear notation. This happens to be isotope 14. I am given this number 14 in my problem set. What I know from the periodic table is that there's an atomic number of 6. That means that there are 6 protons in this atom. Because there's no charge up here in the right corner, I also know there are 6 electrons. And by subtracting these two numbers, I can get the number of neutrons. So in this isotope or this atom, we have 6 protons, 6 neutrons, and 6 electrons, and 8 neutrons. So let's look at an example of copper. Copper has 3 isotopes here. We have copper 63, 64, and 65. All 3 of these coppers have the same atomic number, which makes sense because it identifies the element. So there are 29 protons in each one of these. Because I see there is no charge on here, that means there's also 29 electrons. Now, to determine the number of neutrons, we're just going to subtract these numbers from each other, and we will get the number of neutrons. The first one has 34 neutrons, the second one has 35, and the third one has 36. And that's how you determine electrons, protons, and neutrons with nuclear notation. If you want to know more or have a deeper lesson, find me on YouTube at Kim's Chem Chats, and I will talk to you later.